Buffer overflows, attacks and defenses for the vulnerability of the decade, presented by Fortune Tlalo. Unfortunately, I did not have the opportunity to actually stand in front of class and talk about my presentation, which I thought was very fascinating, very informative, and very engaging. I had it set up so that the class would actually participate in my presentation, give me feedback, but unfortunately, due to snow days and other unforeseen circumstances, I have to settle to a recording. So what is buffer overflow? Essentially, it is when a program writing data to a buffer overruns the buffer's boundaries such that it actually overwrites adjacent memory. This provides opportunity to corrupt or attack a computer system. It's a very big source of vulnerability for computer systems. This is a diagram of how the attack actually is conducted. What the primary goal is to change where the return address is facing when the call returns. So by affecting the buffer, you can actually overwrite. The to overwrite where the actual pointer is pointing, and you can insert your own attack code here, and then when the return call returns, it will go straight to the attack code and execute. And from the attack code, you can actually jump to other attack code or download even more malicious software. According to the paper, the Crispin paper, what they did, one of the solutions that they did, which they call a stack guard defense against stack smashing attacks, is where they add a canary, which is just a variable here, and every time you return, you actually have to look at the canary first, and if the canary is not the same as what you have on record, then you ignore the return address because your return has been diverted to an attack code here, which I think is pretty ingenious. It adds overhead though, but it works. C and C++. This was going to be my question to the class. Why C and C++? Why these two languages? I know for a fact that a lot of us are very familiar with C++. C, maybe not so much. C and C++. What makes these languages pop out in terms of buffer overflows? Well, firstly, there's no built-in protection against accessing or overwriting data in any part of the memory, which is really, really bad. We've got no checking on whether array boundaries have been exceeded. And to sum it all up, I mean, in this internet age, where we've got an abundant supply of programs that are actually coded in C and C++, that is just essentially asking for trouble with buffer overflow attacks. Simple solution to this mess is bounds checking. By bounds checking, all the buffer overflow attacks can be prevented, because once you secure those bounds, the arrays cannot grow and you cannot overwrite stuff in adjacent memory because there's bounds checking. That's essentially the solution to the problem, and I was going to ask the class how this could be accomplished and what issues might arise from this, but since there's no feedback here, we just have to go on to the next thing. This is a table that I borrowed from the Crispin paper, which just shows how they address the buffer overflow problem. And here is the code pointer types. You've got activation record, function pointer, long jump buffer, and other variables. You've got attack code location, resident, stack buffer, heap buffer, static buffer. And the stack guard is a proprietary solution and point guard that the authors came up with, But what I found really fascinating about all this is the buffer overflow, the stack buffer defenses. If you notice, there's stack guard and non-executable stack, and you see non-executable stack is within all these 4 categories here. And this is really simple. If you make your stack such that you can run executable code in it, that prevents all these attacks in the stack buffer. But of course, they added their own other tools to address some of the issues that non-executable stack might have. But that's pretty much interesting. Go to the next next slide. Here we're talking about some trade-offs of actually trying to address this buffer overflow problem in C and C++. First one being performance degradation, with some of the combinations of stack guard and point guard and non-executable stacks. In some configurations, performance can have a degradation of up to 40%, which is really bad. You've got increased overhead. You have to detect and prevent the overflows. And another solution that might not be as practical as the others, you can just redo the code in different languages like Java or any of the .NET languages to solve the problem. I'm going to talk about some exploitations here. We've discussed about the Morris worm in detail in class 1988, which exploited the finger in Unix. I found out about the code red worm, which exploited a buffer overflow in Microsoft's Internet Information Services, which is IIS, in 2001, essentially using the buffer overflow attack. You have an SQL slammer worm, which compromised machines running Microsoft SQL Server 2000, which are all exploiting this vulnerability that I discussed. More exploitations. Now we're in the 2000 era, and we're talking mostly about the gaming consoles here. You've got Xbox gaming consoles in 2003 that were hacked to enable them to run unlicensed software. By that I mean illegally copied games, unlicensed games, user programmed or modified games. Not to be left out, in 2003, PlayStation 2 was a victim of this exploitation, and they used game code independence, and they exploited a buffer overflow weakness that game had to actually configure the PlayStation 2 such that you could play home-brewed games, as the gamers call them. Next was the hack of the famous Nintendo Wii. Here they used the buffer overflow too, and the game that was used for this exploitation was The Legend of Zelda Twilight Princess. 2010, one of the most sophisticated gaming consoles, which is the PlayStation 3, was hacked. They're using 5% firmware and 95% software. And something fascinating about the PlayStation 3, this has one of the most sophisticated chips in it, and it has really amazing computational power. There's a university that actually configured a supercomputer by hooking up, I think it was, if I'm not mistaken, 16 PlayStation 3 computers, and they used this cluster to actually run their simulations. Normally they used to run their simulations on supercomputers where they'd have to borrow time, and time could cost anywhere from 5,000 per session. So there is a lot of computational power, especially in the PlayStation 3, if you know how to configure it right. So this is really significant here. Something that I thought is driving some of these vulnerabilities and attacks is the availability of tools and information. When the Morris worm happened, they tried their best to conceal how the attack was done, since it could be copied really easily. But which I thought was a good thing, that they actually tried to prevent these copying. And unfortunately, in this age and time where everyone has access to the internet and anyone can post anything, information is readily available. There's FRAC at frac.org. This is, they talk about all the hacks. They give you tools. They'll tell you step by step how things are done. YouTube is very famous for instructional videos on anything, jailbreaking iPhones, anything, you name it. They have videos on there. There's actually books on hacking, and a website I found, which is xboxmods.com, actually teaches you how to modify your Xbox. And here's I was talking about books being available for hacking. Here's the Hacking the Xbox. You can buy it on Amazon.com at a price of $15.66, and you can clearly see that these are the inventories are available, where you can buy them for as much as used for $4.39, which is just the sheer availability of information on how to do these attacks is just going to drive people to be more innovative in their attacks. This was gonna be a slide where I was gonna prompt the class to join into discussion and try and drive an argument here. When you buy a car, you're not told where to drive it. When you buy a TV, you're not told what to watch. When you buy a gaming console, why should you be restricted on what to do on it? Is my question. And this was going to be driven by the class. There's a lot of recent events that have taken place of late. The gentleman who hacked the PlayStation 3 actually had the case heard, and I think they're gonna settle out of court. This case is still pending, but it's something that's been happening, and at this part I was actually trying to drive into a discussion, but unfortunately I don't have the privilege of getting feedback or interacting with the class, and which is unfortunate because my whole presentation was around interaction. So we'll just skip this. And this brings me to the end of my presentation here. We've got references from the paper, Crispin paper, Microsoft security bulletins, all kinds of resources here. And that's essentially my presentation for you. It's unfortunate that it couldn't have been longer. It could have been longer how I had it timed with class participation and driving a debate or an argument. It was essentially going to be slightly longer and entertaining on top of informative, but I don't have that privilege. So if anyone has any questions, if anyone actually does watch this presentation, feel free to email me here, right there, my school email, and hope you guys have a good break, and thank you for paying attention. Appreciate it. Bye.